Welcome to Episode 44, Conditional Access and Role-Based Access Control, often called RBAC. This episode focuses on how Microsoft Entra and Azure use policy and role systems to decide who gains access, when, and under what conditions. In modern cloud environments, static permissions are no longer enough. Access must adapt to real-time context. Conditional access evaluates sign-ins dynamically, responding to risk signals before granting entry, while RBAC determines what each user or group can do once inside. These two systems form the cornerstone of identity-driven security, enforcing the principles of zero trust and least privilege. Understanding them means understanding how access becomes both flexible and precise. They allow organizations to maintain agility, comply with policy, and protect assets, all without overwhelming end users. The combination is not just technical, it represents a mindset shift toward continuous, evidence-based authorization. Conditional access operates on a deceptively simple idea. Policies decide who gets what, but those decisions adapt in real time based on context and behavior. Every login attempt is checked against a rule set that weighs identity, device health, network location, and risk level before allowing, challenging, or denying access. Rather than handing out static keys, conditional access constantly verifies legitimacy as conditions evolve. For example, an employee may log in freely from a corporate laptop on a trusted network, but must pass multi-factor authentication when connecting from home or a mobile device. This model mirrors real-world security: more verification where risk is higher, fewer barriers when trust is established. The policy-driven approach empowers administrators to translate security intent into enforceable, measurable outcomes across every sign-in event. Each conditional access policy follows a clear logic: gather signals, apply decision criteria, and enforce results. The signal collection stage compiles data about who is signing in, what application they are trying to reach, and what the environment looks like. Decision evaluation compares those inputs to rules that reflect business policy, whether access is allowed, restricted, or denied. Finally, enforcement actions take place instantly, applying MFA prompts, blocking untrusted devices, or granting session limits as required. This three-step sequence happens invisibly to users, but keeps every session aligned with organizational risk tolerance. It transforms access management from a static checklist into an adaptive control plane that continuously adjusts to context. By linking identity data to real-time enforcement, conditional access turns the sign-in process into a living security measure. Signals are the lifeblood of conditional access decisions, feeding the intelligence that drives each outcome. These signals include the user's identity, group membership, device compliance, geographic location, IP reputation, and detected risk from systems like Microsoft Defender for Identity. For instance, if a sign-in originates from a new country or an unregistered device, the signal weight increases and might trigger MFA or a block. Risk detection also identifies anomalies such as impossible travel, two logins too far apart in time and distance to be legitimate. By combining diverse signals, conditional access refines accuracy, preventing false positives while catching subtle threats. This data-driven approach ensures that policies are neither overly permissive nor unnecessarily restrictive. It brings precision to access control, grounding every decision in measurable evidence rather than static assumptions. Grant controls are the decision levers that determine how conditional access responds to different levels of confidence and risk. They specify requirements that must be met before a session is allowed, such as enforcing MFA, verifying device compliance, or demanding a low-risk score. Administrators can combine multiple conditions, stacking protections as risk increases. Imagine an employee accessing payroll data from an unmanaged device. The system might prompt for MFA, restrict downloads, or fully block access. These layered controls create a security gradient rather than a binary yes or no gate. They let organizations maintain productivity for trusted scenarios while automatically tightening restrictions in uncertain conditions. In practice, grant controls translate business intent into concrete user experiences that adapt seamlessly to the risk environment. Session controls extend this adaptability into the duration of the user's activity. Instead of granting indefinite access once a user signs in, session controls continuously evaluate behavior and context. They can limit how long a token remains valid, prevent file downloads on unmanaged devices, or enforce in-browser-only document editing. Continuous access evaluation monitors signals throughout the session, revoking access immediately if conditions change, such as a device losing compliance or a risk score rising mid-session. This model closes a long-standing security gap between initial authentication and ongoing usage. It ensures that trust is not permanent but conditional, always verified and always revocable. For organizations balancing collaboration and compliance, session controls provide precision tools for controlling data exposure minute by minute. Role-based access control, or RBAC, governs what happens after access is granted. Conditional access answers, should this person get in, while RBA answers, what can they do once inside? It organizes permissions into defined roles, scopes, and assignments rather than direct entitlements. Each role describes a set of allowed actions, such as reading, writing, or configuring specific resources. Users or groups receive these roles within defined boundaries, replacing ad hoc permissions with structure and consistency. The RBA model is both scalable and auditable. It clarifies responsibilities and supports compliance by showing exactly who can do what and why. When paired with conditional access, RBA completes the loop from authentication to authorization. Microsoft provides built-in roles for common tasks and allows custom roles for fine-tuned control. Built-in roles like owner, contributor, and reader simplify deployment, while custom roles give organizations surgical precision over privileges. Custom roles can grant just a handful of actions or exclude sensitive operations that even high-level users shouldn't perform. For example, a custom help desk role might allow password resets but forbid deleting user accounts or altering conditional access policies. Creating such granular roles reduces the risk of privilege misuse while maintaining efficiency. This flexibility allows organizations to align access rights precisely with job functions, making security both tailored and transparent. The ability to model responsibilities accurately is one of RBAC's greatest strengths. Scope defines how widely a role's authority extends, from individual resources to entire management groups. Applying the least privilege principle means choosing the smallest necessary scope. Assigning a contributor role to a single resource group instead of a whole subscription, for example, limits potential damage if credentials are misused. Because RBAC scopes can inherit permissions downward, administrators must carefully plan boundaries to avoid unintentional overreach. Clear scoping not only improves security but also simplifies auditing and troubleshooting. It helps organizations visualize access hierarchies and maintain governance at scale. Proper scoping turns RBAC from a technical feature into a practical policy instrument that reinforces control through clarity. Privileged Identity Management, or PIM, adds another layer of safety by introducing time-based access. Instead of granting permanent administrative rights, PIM enables just-in-time elevation when needed. Users can request temporary roles, undergo approval, and automatically lose privileges after a set duration. Every activation is logged, creating a clear record of privileged activity. For example, an engineer performing maintenance might activate owner access for 2 hours, then return to a standard user role. This drastically reduces the window for abuse or compromise. PIM operationalizes least privilege by making access both scoped and temporary, aligning technical enforcement with human accountability. It's one of the most effective ways to prevent overprivileged environments from eroding security. Access reviews and entitlement management extend governance across time by ensuring that permissions remain appropriate. Access reviews prompt role owners to confirm whether users still need their assignments, catching dormant or outdated privileges. Entitlement management packages permissions, policies, and approvals into automated workflows for onboarding, offboarding, or external collaboration. These capabilities stop access sprawl before it becomes unmanageable. They also strengthen compliance posture by providing verifiable records of periodic review. Together, they transform RBAC from a one-time configuration into a living governance process, one that adapts to staff changes, evolving roles, and new risks while preserving transparency. Auditing assignments and evaluating conditional access policies close the feedback loop that keeps the system honest. Detailed logs show who has which roles, when they were granted, and how each policy has been applied. These insights reveal misconfigurations, redundant roles, or policy overlaps that create unnecessary complexity. Monitoring usage also highlights which controls genuinely protect assets versus those that add friction without benefit. Regular audits and reporting convert access management into a continuous improvement cycle. By understanding real-world patterns and adjusting accordingly, organizations turn static controls into an agile defense mechanism guided by evidence and feedback. Consider a practical scenario where both conditional access and RBAC come together. Administrators may need temporary elevated rights to deploy infrastructure, while standard users require consistent but limited access to shared apps. Conditional access enforces device compliance, MFA, and geographic restrictions, while RBAC confines each user's actions to their domain. Privileged identity management ensures that high-level permissions vanish automatically after use. The result is a layered system that grants flexibility without giving away control. It protects against accidental exposure and deliberate misuse while keeping workflows efficient. This real-world balance is what makes policy-based access design so powerful in enterprise environments. The ultimate goal is a system where policies are consistent, permissions are minimal, and access adapts intelligently to risk. Conditional access governs entry by context, RBAC defines capability by role, and governance tools sustain both over time. Together, they implement least privilege as a living principle rather than a static rule. When done right, users work naturally within secure boundaries, administrators operate confidently with clarity, and auditors find every action traceable. This harmony of protection and usability defines the maturity of modern identity management. Security becomes less about restriction and more about enabling safe, continuous access in a connected world.